There are multiple ways of implementing backend protocol. One of the standard approaches, or one of the first approaches to implementing backend protocol, is this. Okay. Now, this is just a typical 4-step approach to backend protocol, to implementing backend protocol. The step 1 is basically study the specification which is hosted on GitHub. Okay. Then step 2 is define the scope, use cases, and taxonomy. Okay, where you define basically what are all. So this, as Sujit had mentioned earlier, right? The spec actually supports more than around 10 million use cases in e-commerce. Now it's not necessary that every commerce network is going to utilize every single aspect, every field of the specification, right? That's why we said there's a domain specific layering, or even a network specific layering of taxonomies, which restrict the fields which are being used, and ignore the fields which are not being used. So that sort of comes from defining the scope of a network. That usually starts by defining, hey, this there are, say for example, there are maybe 5 buyer platforms to maybe 10 seller platforms, a couple of gateways. They all come together and decide, okay, what is going to be the scope of my network? Okay, what's the domain of operation? Okay, what are the use cases, right? Even if this, say for example, if I select one single domain like mobility, it itself has so many use cases. Like, am I doing cabs? Am I doing bicycle shared riding? Am I doing carpooling? Am I doing buses, metros? The list is endless, right? And so you define what are all the various domains and subdomains. And even within a particular subdomain, like say cabs itself, it has got so many use cases, right? Am I doing shared cabs? Am I doing spot booking? Am I doing advanced booking? Am I doing rental? Am I doing outstation? There are so many other use cases which need to be considered before implementing the specification. So you define the scope, use cases. Then once you have defined the scope and the use cases, you see what fields or what objects in the specification are relevant to those use cases. And then you publish a domain specific specification which says that, hey, for cabs, for just cab services, this is the specification which needs to be used, and the rest can just be ignored. Okay. Now, when I say this is the specification, I mean deciding which APIs the platforms are going to implement, which schema objects are going to be there, what are the required fields in each of those schemas, what are the enums in each of those schemas, what are the formats and standards which are used for each of these schemas. Okay. So once you have defined that, you finally get a bare bone. You get a domain specific instance of the core specifications. Now, once you have that domain specific instance, then you start implementing your APIs. It sort of starts off with your API itself. Okay, the protocol APIs. First, you implement that, like search, select, init, and confirm, as I had mentioned earlier. Then, obviously, you must have realized that, hey, these are all async APIs. Now, how do I actually translate that into client APIs? Because most of the APIs which we use in our mobile phones, etc., are all synchronous APIs, which means that you get your response in the same session, right? Which means that there is a sort of a translation layer which sort of integrates the synchronous API layer with the asynchronous API layer, right? Now, the mapping can be done via various forms. Either you can do a typical polling, which means, like for example, I did a search on the network, and then I know for a fact that I will not get the response in the same session, which means that there has to be a way where I need to check whether I have received the on search response, right? Which that can be done using creating a client API called check search, or you can also do WebSockets where there is an open socket which keeps listening for any incoming callbacks. Right? That's also one way of implementing the client API layer. Then once you have the client API layer, then you implement the client UI if needed. Okay, maybe you already have a UI, you don't require any separate UI for your for implementing Beckn, and then you're just performing, you're just creating a web service. Maybe you don't require a UI at all. Okay, so there are lots of use cases where you might require one or more of these layers which you see in front of you. Okay, we'll go slightly more deeper into each of these layers later in the second half of this session. But the third step is essentially to implement all the layers of the protocol. So this is your protocol stack, which you call it protocol APIs, domain APIs, and client UI. Okay. Once you've implemented, as I said, it's just implementation is not enough. You have to get yourself certified. Then you have to register on the registry infrastructure, and then finally subscribe to the network. Okay. Now these are interesting terminologies which we will go into the next section, which we'll discuss in the next section, which is the infrastructure layer. Now, this is a very important layer, because this actually defines the transition between this sort of, what do you say, facilitates the transition between a platform which has implemented the specification into actual live transacting entities on the network. Okay. Now, as we had mentioned earlier, that the infrastructure layer sort of looks very similar to the DNS infrastructure, and also looks very similar to the chain of trust, right? Which means that there are various levels of registries which are available, which any platform can get listed on. Okay. Now, how does that happen? Now, once a platform has implemented their specifications, what the first thing they are going to do is, obviously every platform will have an endpoint, right, where the API needs to be called. Okay. Now, once they have the endpoint, okay, the platform generates a key pair, basically in an asymmetric key pair, where it keeps the private key with itself and actually publishes the public key on this infrastructure. Okay, on this table. So each registry which you see over here is nothing but a flat lookup table containing these columns. Okay, it will contain the subscriber ID. It contains the type of subscriber. And when I say subscriber is nothing but the platform which has been registered on the network, right? The network participant which has actually been registered, who has registered the platform onto a particular registry. Okay. So this registry exists as a separate infrastructure, is not directly involved in every transaction of the network, but this registry infrastructure is the one which actually allows authentication of every transaction, which means that if you are not listed on a registry, which means that you are not allowed to transact on that network, right? If that network requires a registry, but yeah, basically to discover platforms on a particular network, you require this registry infrastructure. And if you want to transact, you need to be listed on one of these registries. Okay, when you want to be listed on one of these registries, you basically need to provide your the domain of operations. You require to inform what country you are operating in, what city you are operating in, and what is the type. Are you a BAP? Are you a BPP? Are you a BG? Are you another registry itself? Okay, and then the endpoint, and obviously the signing public key and the encryption public key. Okay? And once you have registered, once you have provided these details to your local registry, this local registry basically sees whether you are sees whether you are actually compliant based on what are the network compliant to the network rules and policies of the network. So how does it test whether you are actually compliant or not? Now that comes from a separate infrastructure, which is either a certification agency, or it also the registry could itself have the rules of the network which need to be complied with before adding a particular platform to the registry. It could start from very bare bones documentation for say for example, if you're doing something in healthcare, if you have built a protocol stack in say mobility, it requires a certain level of compliance with the local rules and policies, like for example documentation, permits, etc. If those documents are available at the have been submitted to the person who is hosting the registry, then you are sort of qualified to transact on that network, and that the owner of that registry actually lists your platform as a record in the registry in the registry infrastructure, basically. So usually the entity which hosts your endpoint or hosts your platform details on a particular registry is generally called as a network registrar, but that's not a very standard name over here. It can be called anything, but more importantly, that entity will have implemented a set of APIs for the local registry. Now, once these platforms are listed on that registry, there is a particular way for these platforms to actually subscribe to a particular network. Okay. So there are some specific APIs which are implemented by these registries, which any BAP, BPP, and BG will have to continuously sort of keep updating the registry with their status that, hey, I am available to transact today using those APIs. So there are certain APIs which these BAPs call the registry to say that, hey, I'm ready for today. Okay. So there's an API called subscribe, which the BAP will actually call saying, okay, I'm going to transact today for 24 hours. And these APIs are generally called once in 24 hours to sort of show your presence on the network. So this is one of the functionalities of the registry. The other way, the other functionality of a registry is to actually facilitate lookups. For example, if a BAP wants to discover what are all the BPPs on the network, or if a BG wants to discover what are all the BPPs of a particular domain, inside a particular city in a country, of a particular network, then the BG will actually call an API called as the lookup API to these local registries. Now, these local registries will sort of, return all the BPPs which match a particular set of domain, city, and country, and then the BG will broadcast your request to those BPPs. Similarly, there are as you go higher, actually there are country level registries and there are root level registries. These country and root registries only have other registries listed inside them. Which means, and why is that? For example, this is actually to facilitate transactions which are not originating in a particular location. For example, I am, say, in New York and I want to book a cab for my parents who are in, say, Bangalore. Okay. Now, how do I discover what are all the mobility agencies which are operating in Bangalore? Either I sort of download an application which operates only in Bangalore and do this, but if I have a backend enabled application with me, the way to do that would be like this, right? The application will call its local gateway and say, hey, can you find me all the cab providers inside Bangalore? The local gateway in New York will say, hey, I don't know what platforms are currently present in Bangalore. Please please contact the root registry. So what I will do is I will actually fire a lookup on the root registries, and I will ask the root registry, can you tell me all the country level registries? Can you give me all the country level registries which are operating inside India, right? And this root registry will give me all the country level registries, and then I will query these country level registries. I'll pick up any one of these registries and say, hey, can you give me all the registries, local registries operating in the city of Bangalore? Now, this country level registry will give me all the local registries that are operating in the city of Bangalore, and then I will choose any one of these registries and say, hey, can you give me all the BPPs which are available in Bangalore in the domain of mobility, in the domain of mobility, basically. So this local registry will give me all the BPPs which are in the city of Bangalore, and after that, I can simply start transacting with them. So this is very similar to how a typical DNS lookup also happens. DNS lookup actually happens like this, like when you type in a domain name which is not familiar to you, the first thing which the local DNS gateway does is it first looks up the root, the TLD server, which is called the top level domain server, right? And it gives you the addresses of all the .com or the .net servers, and then you look up at the .net server and you look at your domain and actually query your .com or the .net servers to give you all the endpoints which are currently compliant with .com, and then ask it to look up a particular address on the lookup table, and it gives you the actual address of the platform you're supposed to be transacting with, right? So this registry infrastructure has been sort of modeled after the DNS infrastructure in a very similar way, which allows any BAP, BPP, and BG to transact or to actually look up the BPPs which are available in a particular region, in a particular country, and actually transact with them without actually being in that country. So that's the registry infrastructure in general. So once you have implemented your protocol stack and you're listed on your registry, then you're ready to transact on the network. Okay. Now, transacting on the network is, as I told you, is a very typical flow, just like which, as I had mentioned, it has search, select, init, confirm, all these APIs which allow you to emulate various events which happen in a typical commerce transaction.